Hi, everyone. This is Jane Ju. I'm a senior software engineer from storage engineering team in Bloomberg. And my today's topic is keeping Ceph RGW object storage consistent. Hello. Still doesn't work. I'll just stick here. And here's our agenda. I'm going to start with a brief introduction of who we are, then a high-level summary of how our Ceph clusters look like, and then I'm going to dive into some real cases of RGW data inconsistency that we have encountered in the past 1 or 2 years. And then I'm going to propose a way to keep RGW data consistent, that is bucket scrubbing. And I'm taking questions at the end. So first of all, who we are. Bloomberg. Bloomberg is a financial technology firm founded in 1981, and we provide data services, news, analytics, and software to financial institutions. And we have more than 350,000 subscribers in 170 countries. And we process more than 400 billion pieces of financial data each day with a peak of 10 million messages per second. And we have more than 9,000 engineers worldwide. That is Bloomberg. Okay, our storage engineering team, and we design, builds and maintain all type of storage products for a Bloomberg engineering team. And we provide appliance-based storage as well as software-defined storages. And in terms of storage type, we support file storage, block storage, and object storage. And we also provide data protection and support storage workflows and automation. And for my particular team, I'm part of a distributed storage teams, or distributed storage teams focus on software-defined storage. And we support block storage, which is in collaboration with our compute engineering team, and object storage. All of those, like both are backed by Ceph. And today our focus is our S3 cloud object storage, BCS, because it's object storage, so it's heavily RGW focused. And we have extended our clusters a lot in the past couple of years. And right now we serve more than 2 billion S3 requests per day. And we have 10 Ceph clusters across 4 data centers. And here's our scope. We provide around 77 petabyte of raw storage and around 4,500 OSDs per data center. And we support around 2,000 RGW tenancies and 450K buckets per data center. Here's a high-level architecture of our Ceph clusters. Our Ceph clusters come in pairs. Each pair has 2 data centers, and each data center has its own Ceph cluster, and they are in RGW multi-site settings. And the multi-site replication happens on RGW data across data centers. And because today our topic is RGW data inconsistency, before we dive into the inconsistency part, let's look at a high-level data layout of the RGW data. We will not include all the RGW data today. We only focus on buckets data and the objects data. Here's a high-level data layout. And those data scattered across multiple pools. And for example, for the metadata pool, we have a list of buckets per user that is in the OMAP. And for each bucket, we have an entry point, and also there's a bucket instance object. And for all the objects in a bucket, they're listed in bucket index, which is in the index pool, along with the bucket index log, which is to facilitate multi-site replication. And of course, the real data in the data pool, And each S3 object has a head reduce object, which may or may not contain the real data. And it's along with a number of tail objects. And there's some other supporting data, for example, metadata log, sync setters data, etc. Those are here to help on multi-site replication. And also, LC shards contains a list of buckets with life cycle policies. That's for life cycle processing. And also GC shards for garbage collection process. So we can see, oh my God, I'm sorry, how do I go back? Okay, we can see there are a lot of data. This is scattered across multiple places. And it's hard to always keep them consistent, especially in a very large-scale system. And but from our experience, so majority of our data inconsistency cases actually caused by some kind of recent conditions. And why is that? First of all, as I mentioned, data is scattered across multiple places, and for the performance purpose, majority of the operations are async, and some operations are not atomic. This is causing a lot of trouble. And also, in-memory cache is unavoidable, but when it involves with some RGW instance crashes, it may cause troubles because some of the data may only exist in memory. When the RGW crashes, those data are lost. We'll have some real cases for this later on. And things are getting more complicated when multi-site replication is involved, especially in the active multi-site settings. What's the consequences of data inconsistency? First of all, it could give out wrong data to S3 requests. And it could also have potential data loss. We have this use case as well later on. Later, I'm going to talk about that. And the data also could permanently different from its multi-site counterparts. And there could also be a large number of hidden widths of storage space. We have encountered all of this, and they're going to be mentioned when we dive into the real cases of data inconsistency. In terms of data inconsistency scope, it could happen in local zones, and it could also happen across multiple zones in multi-site settings. Of course, they should be handled differently. Okay, now let's dive into some real cases of data inconsistency that we have encountered in the past couple of years. The first case is involving some orphaned multi-part parts. We got a lot of client complaints saying that they've got those space quota exceeding alerts, but when they look at the the size of their real data, it's actually far less than their allocated quota limits. Why is that? After some analysis, we found out actually it's caused by some orphaned multi-part parts. Here's a very high-level graph to talk about what's happening when a multi-part uploads is ongoing. So those blocks in this graph are S3 objects, not RADOS objects. So when a multi-part uploads is ongoing, some of the intermediate objects are being generated. For example, we generate a meta object and along with the list of parts. And when multiple uploads completes and a new S3 object, final S3 object is generated on top of those intermediate objects, and the information for those intermediate objects is going to be cleaned up. So there must be something wrong during this process. So some orphaned multi-parts are generated. So what went wrong? So we identified the root cause actually is caused by a recent condition. Here's what's happening. So it's basically caused by a prolonged put request for the last part. In this particular case, the put request for the last part takes extremely long. So from client side, this request times out. So it's being retried. And actually, the retry finishes very fast. And immediately after that, the multi-part completes, it's triggered. And when it reaches the end of the complete, and a new S3 object is created, and all the infos for the intermediates objects are cleaned up. But this cleaning up doesn't include this previous prolonged put last part request, because it hasn't been back yet. So when that prolonged put request comes back, it already missed the cleaning up phase. So that last part left behind. So that is how this orphaned multiple part is generated. In our case, because for our clients, it is very heavy workloads for multiple uploads. A large number of those orphaned parts are generated. So those parts are hidden from clients, but they occupy the real storage space. Actually, this issue has been resolved. Here I posted the tracker and PR. I believe it's going to be available in next Squid release. And the second case is OH update racing condition. It happens in multi-site settings on version bucket. What happens is the object versions are inconsistent across multi-site zones. To be specific, in our case, a new version, which is a current version on the primary zone, and is failed to be promoted to the current on the secondary zone, hence the inconsistency. And it actually caused data loss in our case, in our RIF version, when the LC is involved. We identify the root cause. It's a racing condition on epoch versions on the object OH entry. Here's what happens. So these are like two zones in multi-site settings. And we can see the primary zone. Those are there's some requests that update the OH epoch entry, epoch version. Those pink lines are replications between the multi-site zones. And there are some other updates could be initiated from the secondary zone as well to update the epoch, OH epoch version. And in our case, those updates are initiated from a lifecycle process. So let's look at this request on the primary with version 3. That's a put request to put a new version on top of a versioned object. And before that one can be replicated to the secondary, some other updates on the secondary, in our case from lifecycle processing, are initiated to increment the OH epoch version like to 3 and 4. So when this request with version 3 reaches to the secondary, it noticed that actually the current OH epoch version on secondary, which is 4, is larger than the ones that it carries, which is 3. So in this case, some of those operations are skipped. In this case, the operation to promote the version to the current is being skipped. So that's how the inconsistency is generated. So this is still work in progress. I post the tracker here. And the third case is data log crash consistency. It's also in multi-site settings. Actually, we identified this in our pre-release stress testing in the multi-site settings. So after the multi-site replication is done, we noticed some missing objects on the secondary zone. And after some analysis, we identified multiple root causes for this. The data log crash consistency is one of those. And we know for each bucket shared update, a corresponding entry will be added to the data log. But RGW actually doesn't update the physical data log on each of these updates. It actually caches all of the entries in memory before committing to the OSD in batches. But if like a RGW instance crashes, before those entries are committed to the OSD, those entries will be lost. So the replication on those updates will be skipped. So this is like a work in progress. Work's being done by Adam Emerson, and along with some C++ 20 code routine changes, here's a tracker and PR. And as I mentioned, we identify multiple root causes for our multi-site data inconsistency within our stress test. And I listed two others. One is unfinished bucket index transaction for some reason. So either bucket index log entry or data log entry are lost. So of course, those corresponding multi-site replication will be lost as well. And the second one is the racing condition between bucket transaction completes and data sync. This graph shows how it happens. So this async bucket index transaction completes takes extremely long for some reason. And towards the end of the complete entry should be added to the bucket index log. And also along with that, an entry should be added into the data log as well. However, this adding to the data log doesn't happen after everything is done. It happens in parallel. In this case, is adding an entry to data log finishes very fast. And in our case, data sync for this kicks in very fast, very quickly as well. So this data sync would retrieve all these entries from data log, and then later on retrieves all these entries in corresponding bucket index log. But those retrieved entries from bucket index log don't include the very last bucket index log entry along with this bucket index transaction. And after the replication process is done with this bucket index log shard, it thinks everything caught up, but actually it's not, because we still have one last bucket index log entry left behind. If this is not the last update for that particular bucket shard, that's fine. It could be like picked up with the following update. But like in our case, it happens to be the last update for that particular bucket shard. In this case, that entry will be left over forever. Nobody gonna, no more like replication process gonna pick it up. So that update is also like lost forever. For these two root causes, it's still in the stage of exploring solutions. For the unfinished bucket index transaction, there's a PR to add a data log entry after there suggest changes in bucket listing. But we have a problem here because this can be only done when an administrator run this RADOS admin bucket listing explicitly. So we need a more active and a more automatic way to achieve this. And also for this like recent condition I just talked about, there's an idea to make use of async data log update. Here's some documentations for this idea. I posted here as well. Okay, that is a far from exhaustive list. There are many other like, data inconsistency cases, but because of the time limitation, we cannot examine all of this. I listed some others here. Some of those are encountered by us, some of by the community. For example, one of the inconsistency between indices and data, like many like often things, often object indices, often object data, like often tail, RADOS objects, etc. And also we have encountered some LC shard inconsistency across multi-site zones. In our case, we noticed some leftover entries on secondary zones for deleted buckets, and also some other leftover data for deleted buckets there's ongoing effort by the community for the multi-site, in multi-site settings, just to clean up those leftover data. And we also encountered one we suspect it's in the local zone. It's only in the local zone, but we're still investigating that. And also some inconsistency involving bucket resharding, etc. So there are a lot of data inconsistencies. How we fix those? The most effective way is to fix the underlying issues. But this has problems. First of all, it takes time to identify the issues, and we believe there are still many data inconsistencies have never been discovered yet. And the second, it takes time to fix the issue. And third, because development work is always ongoing, new features and new bug fixes. So basically, we can never have a totally data inconsistency-free system. So we need an active or probably automatic way to report potential data inconsistencies and potentially auto-repair those. This could also help us to repair damaged data after underlying issue is fixed. In order to achieve this, we propose a solution, which is to run a bucket scrubbing as background tasks, just like PG scrubbing, but instead of a PG, we act on the S3 data at bucket level. Here's some requirements for this bucket scrubbing system. It should do a per bucket consistency check, and it should run on background, and it should support some like extendable modules, and each module can handle one type of data inconsistency, and it should remember the progress, so we can just distribute the workload across multiple runs. And the workload should also be configurable, so we can configure like how much we want to run based on our real use cases to make sure it has a minimum impact on other RGW workloads, especially on the client traffic. And it should support two modes, report modes and auto repair modes. It should also be configurable. And it should also be able to run on demand. We are thinking about extend reduce admin bucket check command to achieve that. And in terms of the inconsistency scope, if it happens in local zones, the bucket scrubbing should report and repair inconsistencies between indices and data for this unfinished bucket index transactions and for all orphaned indices and objects, and for missing tail reduce objects, etc., and also for inconsistency in the LC shard, all of this. If it happens in multi-site zones, and it should report and repair missing data log and BI log entries, and metadata inconsistency and data inconsistency, etc. I listed some examples for each of those inconsistency cases. And here's our proposed high-level architecture for bucket scrubbing. And we should have, like, for example, bucket scrubbing shards to keep a record of a list of buckets as along with this bucket scrubbing status. They could be in a log pool. And we should have a number of bucket scrubbing processors, like run by like in single multi-threads in parallel. And like each processor should run a different type of a consistency check module, and each module, as I mentioned, taking care of one type of data inconsistency. It examines either data in local pools or across multiple zones in multi-site settings. For those extendable modules, and each module handles one type of data inconsistency, we should have an interface to register module. We should have a framework to run modules in parallel. And to define a module, we should define a data scope and define what is the inconsistency on that data. And we should have a component to collect information, a component to do this consistency check, and a component to report any inconsistency, and a component to repair the data. And as I mentioned, workloads should also be configurable. Here's a proposed configurable options. I will not go into the detail of that. And we are thinking about making some like prototypes. So like if for those inconsistencies happens on the local zones, the scope of data to verify would be indices and data and object versions, bucket stats, and LC shards, etc. And we can make use of some existing tools and ideas. For example, we can make use of the current RADOS admin commands, bucket check, and object reindex. And also there are some existing experimental tools that we can leverage. And for example, this RGW restore bucket index and RGW orphan list, etc. For the prototype, for the multi-site inconsistency, we could use S3. We are thinking about using S3 requests to retrieve information from remote zones, and we can use the E tag to verify the object content. Its existing functionality is controlled by a configurable RGW sync object E tag verify. And in the multi-site settings, it's a little bit complicated, more complicated to pick which buckets to scrub, because in the multi-site settings, it's legitimate for a bucket to have this different content as long as the replication is ongoing or there's a bucket replication policy involved. So it's very important to pick the right timing to scrub that bucket. So we're thinking about using this replication status idea, but again, we're still exploring the ideas at the moment. And there's some like other existing ideas that in some other ongoing efforts that could be used here. For example, this deleted buckets OMAP idea, like in this effort to clean up some like leftover data for deleted buckets. So if anybody is interested, you can go to that PR to take a look. And our future plans. So our plans after we discuss this, our design with the community, and we're gonna build a framework for this. And on top of the framework, we are planning to build a couple of prototypes, modules. Our plan is to start with the multi-site replication consistency check. And after that, we're going to do some performance analysis to benchmark it and also evaluate the impact on other RDW workloads, especially on the client traffic. And at the same time, we would like to solicit the community's efforts to help build on like other modules on other that all different type of consistency check. Yeah, that's all I have for today. I'm taking questions. Thank you. Thank you. It's actually not outside of RGW. It's still done by RGW, just like a lifecycle process. But it's just a background so that it can be independent from like all other processes and always running a background to, yeah.
Okay. So I think it's my response is that probably don't need a module registry. It's probably just something that has a steadily growing set of schema checking capability.
Right. The reason why we wanted the extendable module is because the module, like, we don't know how many like, data consistency involved when the data grows. So in this way, we can just make it more granular and make it easy for all these different developers to chip in on this like effort. And also, it's very controllable. If like somebody is more interested in this type of data inconsistency, they can just deregister the others or.
So the goal is to be able to load code after deploying RGW without changing it? Because that's what they think you've got. Is the goal to be able to load modules in existing version, already deployed versions, and have them asynchronously loaded? That would be the one thing you've got.
Yeah, but we haven't decided on that part yet. It's, yeah. Yes, actually, this data inconsistency check, we focus on only on I3 objects. Of course, it's going to have impact on when it's fixing it or other parts of the system. That's why we have like the workload configurable, so we can configure how we want to distribute it, the workload. And based on your real cases, like the scale of your system, or the client, for example, client traffic pattern, etc. Is this what you're asking? Or?
I asked that. Your measure, I don't know that it's the right question or not, but we're talking about all of these modules about the RADOS component, okay? Yeah. But imagine that, and you're fixing all of this. Imagine that you identify and you want to fix it, okay? Yeah. During this fix time and repairing time, definitely the larger mathematical can affect the OS's performance. Is this repairing can detect this kind of issue there? Or, for example, if it stop and it waits for all the large object to have fixed and after that everything after that will be fixed automatically. I don't know. Because it's not, I think it's not just related to the RADOS cafe, it can affect the deeper component.
Yeah, that's right. But for this fix, I think this is more complicated. We can, for some of those, the inconsistency data fix, we are thinking about doing it case by case, because some of those can be auto repair, some of them cannot. It has, as you talked about, has a larger impact. And so the first phase is going to be a report all this data inconsistency, and we're going to take a look at what type of data inconsistency. Some of those can be configured auto repair. And also for those large OMAP issues that you're talking about, I don't think it can be, it's the scope of this data inconsistency check. It's a totally different issue, really. Yeah.
It's a RADOS cafe, but it impacts the OS. And imagine that you have the RADOS cafe and block storage, both of them, where set cluster remodelism, okay?
Yeah.
This can impact other clients to read and write from the cluster. It's already wrong. And because of that, I asked you that it's about just the RADOS cafe, or check all of the cluster status and say, okay, during this repairing, I take care of this module and this issue.
Yes, I think after we prototype it, we probably have a deeper analysis for on all the type of data inconsistency to check what's the impact to repair those. But at this point, we are not there yet. We're going to do some analysis on this.